Hi, everybody, and happy Tuesday. We're going to start off today with some decimal operations by solving each of these questions on the top and then rounding them to the nearest whole number. So, starting off at the top, when subtracting and adding decimals, I always think about starting with the whole numbers. So we have 57 minus 6. I'm going to go over to the side and do 57 minus 6. And then after that, I always add in that decimal point at the end. So, and 258 thousandths. Then to my 57, I can just add 0 thousandths here. Now, one thing to keep in mind is as we look at this, kind of think of it starting with the whole numbers, 57 minus 6. I know that 57 minus 6 is going to give me 51. So then all I'm doing is subtracting away 258 thousandths from that, which is going to be then less than 51. Thinking about starting with the whole numbers can be really helpful, and it can tell us about where our answer is going to be. All right. On the second question, we have 73 times 4 and 41 hundredths. So the first thing I notice is that 4 and 41 hundredths is close to 4. So I'm kind of thinking of what is 73 times 4. Well, I know two 73s are going to be more than 100. So I'm assuming that four 73s then are going to be more than 200. So maybe 200 and something. So when I do this, what I'm going to do is start off by moving that decimal over 2 times in 4 and 41 hundredths. So basically, I have 441 now times 73. And then when I get my final answer there, I'm going to have to divide it by 100, do the opposite, by moving the decimal back 2 times to the left. And that's going to give me my final answer. And we want to make sure that our final answer is pretty close to what we said it would be, something in the 200s. All right. Third question. Notice what we're doing here is we are dividing by 1,000. We've talked about how it's really simple to multiply and divide by 10, 100, and 1,000. Every time you move the decimal to the right, that's the same as multiplying by 10. So moving the decimal to the right twice is like multiplying by 100 or multiplying by 10 twice, 10 times 10. By 1,000 would be moving it 3 times, 10 times 10 times 10. The opposite when we divide. So I'm going to take 462. Notice there is no decimal point in that number, but we can put one right here at the end. 462, moving that decimal backwards 3 times. 1, 2, 3 times. There's going to be my final answer. 462 divided by 1,000 is 462,000. And lastly, 45 and 24 hundredths divided by 6. I'm going to move that decimal over 2 times, multiplying by 100. 4,524 divided by 6. And then just remember that you're going to have to move it back twice there in the end when you finish. For any of these, when you're looking at your numbers, always think about what your whole numbers are and what kind of answer would make sense. And we can kind of work from there. All right, moving down the page. Let's go to the next part. I see simplifying each of these fractions. So we're trying to look at these fractions and put them in more simple terms. So notice they all have a fraction and a whole number. When we're simplifying the fraction, remember the whole number is going to stay the same. So here we're definitely going to end up with 8 still. But when we have 8/12, what I'm kind of thinking is I'm looking for the greatest common factor between 8 and 12. What number can I divide both of those things by? That number is going to be 4. I'm going to divide each of those by 4. And that on the top is going to give me 2. And 12 divided by 4 is 3. So that's all it's really taking to simplify these, is looking for what is the greatest common factor. Now, what if in this case, instead of dividing by 4, what if you had taken 8/12 and divided by 2? You would have come up with 4/6. That's fine, but then you would have had to divide by 2 again. Dividing by 2 twice in a row is the same thing as dividing by 4. So It's thoughtful to look for the greatest common factor from the start. What is the biggest number that I could divide each of those by? That's a good place to start. All right, to our word problem. Owen is determined to get to Super Bowl 45 next year to see his favorite team, the Browns, play. To raise some money, he is having a bake sale. Unfortunately, he doesn't know how to bake, so he decided to hire a professional baker for $5,000 per hour. Let's write it down. That's in our information. $5,000 per hour for baker. All right. After the baker worked 3 hours, I'm just going to put 4 hours. So he rented that baker for $5,000 per hour for 3 hours. Owen was ready for the bake sale. On the first day, he sold 19 cookies for 25 cents each. Uh, 25 cents. And he sold a cake for $25. So a cake for $35. He had to donate the rest because it was going bad. How much money did Owen lose? Okay, so how much did Owen lose? So first off, we got to think about when we're thinking about how much did he lose. We're thinking about first what did he spend and what did he earn. Well, what he spent was this part over here where we see $5,000 per hour, and he did that for 3 hours. So basically, in that case, I'm taking 5,000 and multiplying it by 3 because he paid for that for 3 hours for a total of 5,000, 5,000, and 5,000 for a total of 15,000. Now, from this point, I need to know what did he make? Well, he first made the cake, the money for the cake, which he finish on that, which was $35. And then we know he sold 19 cookies for 25 cents each. If I can find the total of what he made, I can subtract that from what he lost, and that's going to tell me how much money that he ultimately lost in total. So I'm going to let you guys actually figure out the rest of that one, which I think you can do, and to see how much he lost in total. Good luck on that, and I'll see you guys in class.